Yes. Yeah, we are coming back to the chapter 2 again. Yeah, we continue to chapter 2. Okay. Yeah, chapter 2. We're talking about inference about process quality. Okay. The first section, we already have one example, and we have finished about two points. The first point is about motivation, called shortcut. Second point we call estimation. Here have to understand. Okay. And the third point we have interval of estimation. No, not the third point. It's a one point inside estimation. Interval. Okay. Intervals. So we have few example. I hope you guys have conducted at home. So the last point that we're going to show you today, not today, but this second section is about the hypothesis test. Hypothesis test. Okay, yes, this is the last point. So from the hypothesis test, this is not the first time for you to think the word hypothesis. We mean we need to have two parameters to confirm. So whether it is okay or not. It means we have 2 points. We have null hypothesis and one hypothesis. Null hypothesis normally it's going to reject the same pole, mean the same pole. It rejects, okay, and if the H1 rejects H0 rejects, H1 must be accepted. Okay, must be accepted. This is very normal. Is 1 reject, this must be 0 reject, 1 is must be accepted. I mean, this is alternative from 1. Okay, alternative from 0. Okay, so so we normally we have 3 things that going to show you. Let's say this is some example only from the lectures. You check here X0. Let's say example. Let's say X zeros from the both sides. Who is for 1.5. Okay. So H1 it must written like this. 1.5. This is we call both sides hypothesis test. This is called both side hypothesis. So if we want to we want to check the upper side, we want to check the lower side. Check upper side and lower side. I mean, this is both sides, right? And if we want to check the upper side and lower side, H1 will come back something like this. Which equal 1.5, and then H1 it must be bigger than 1.5. This is the upper side. This is upper side. So you want to talking about the lower side, the same thing, 1.5. Okay, and H1 is smaller than 1.1. This is the lower side. This is the lower side. Both side, upper side, lower side. So this is the hypothesis test. So we are going to check. We going to test the testing. Going to reject X0, or we're going to accept H1. Okay, H1. So the two hypotheses to completed proportions, we call null hypothesis here, and H1 alternative hypothesis. I mean, if this one reject, this one must be accepted. Yes. Okay. So we have some procedure that also same thing that they have the procedure. But first one, we have the procedure of the hypothesis test. First, we have to conduct the null hypothesis. We have to find the H1 and H0 and H1. The second one, we have to specify the interval. This is the procedure. What is the alpha level? Yeah. And the third one is to find the distribution for test and reject regions of H1. You need to find the distribution. There are normal distribution, we have partial distribution, we have a binary distribution. This is the distribution. Yeah. First one, you have to collect data. You have to collect the sample. Okay, this is first. And last, not the last, but the fifth one, you're going to compare the test statistic with the reject region. The test statistic and rejects region. This is going to check. And then the last one is to assess the risk. To assess the risk. Okay. Okay, this is the last one. But one actually here is the most important. Because from the distribution, you will find easily the reject regions. So doing the calculation and then compare. Is it whether it is inside or outside of the reject region? Is inside the reject region? Inside the reject region, it means that you have to reject X0, mean reject all the sample. So, whereas alternatively will be SMH1. This is if no, this one no, must be this one yes. Not, we cannot say no and no. Yeah, we cannot say no and no. One no, one yes. One no, one yes, one no. One no, one yes. This must be the same. Okay. So continues. We continue. This is some inference mean of the normal population variant. Okay. So unknown mean the population variant mean we are going to find whether we're going to find H1 and X0 from the reject region. If here we have both side, we have upper side, we have lower side, yeah, upper side and lower sides. Okay. Okay. So from this we are just going to use the normal distribution. For this table, we are going to use the normal distribution because you see here is talking about the alpha level, alpha level with Z value, which is represented from the normal distribution. Okay, from the normal distribution. So please remember all terminology. Remember all terminology, how to calculate the mean and comparing to. Yeah, I will explain you this very carefully because I do hope you guys do not lose the point. Do not lose the point because this point is important. Because this point is important. So from here, just say, okay, from the first one. First one, if you say the first one you have to do calculate from the estimate, some the estimations. This is the mean of the calculations. So whether in case of the calculation from the estimation, this mean of the population divided by sigma over n is the number of the sample size you have to select it. Whether it is bigger than z alpha over 2. Z over 2 you have to find from table. This is the point that mentioned in the procedure of point number 5. Point number 5, you have to calculate this one and compare it to the reject region. This is the reject region. If the cosine here, okay, this is a normal equation. Here this is a confidence interval, CR. This is the reject region. This is the reject region. Reject region. Okay, this is the reject region. Okay. So let's say yours here, calculation coming to this point or coming to this point. For sure, it must reject x0. It must and accept h1. Reject x0, accept must be accept h1, right? So this is the first side of calculation. So what you do, you have to calculate this one and comparing to the reject region. This is the reject region that they are mentioned. This is the critical value. Okay? This is the critical value. So if you are talking about you are going to check the upper side, if you are talking to check the upper side, you need to compare with what? We have to compare with Z alphas. If lower side, you have to compare with the Z alpha same minus. Yeah, this is important. This is important now. You have to understand. The same calculation of mean. And then you compare with the reject region. If whether it is inside or outside. Is inside accepted. If in this reject region, H0 will be rejected. And H0. Okay. Okay, we continue. Okay, here we have one example. We have one example for you. Okay, we have one example for you. So this example is talking about the response time distribution computer system. It's an important quality characteristic. The system is when I want to know whether the mean response time to the specific type of the common demand exists. I mean exists. The word exists 75 milliseconds. 75 milliseconds, sorry. Okay. Exists 75 milliseconds. That the experience of the mean response time we call about standard deviation X millisecond. M second, okay, M second. Okay, and if the command exists 25 times, command execute 25 times and 25. Okay, for the trial is recorded, the sample average we call X bar 79.25 millisecond, the same. Okay, you're going to compute. You are going to compute all the data is written. So this is you do testing the hypothesis from the low and uppers, and then find the confidence interval. We need to find the lower and upper in the confidence interval. So in the confidence interval, the CI is 95. So please do it. Yeah, you can do it. Very simple, right? Very simple, right? This one, they ask you to find whether it exists. Means they only want you to test the upper only, because is it exceed 75 seconds or not? They want to test it is exceed the 75 seconds or not for the mean to the mean. Okay, so you in this you want not you're going to test the upper side, only one. You need to test the upper side. Okay, you're going to test the upper side control limit. So test the upper side control limit. You need to find out. Whether the X bar minus mu over sigma squared is bigger than this one. This is the upper side. No, this is the upper side. You test the upper side. If qualified, this formula means H0 region. If not, I mean H1 is that. Oh no, H1 is that. H1 rejects. Okay. So what if I is 2? Whether the reject region is bigger than this one or smaller than this one. Okay. So I think that enough for you, for some your ideas. It's supposed to be okay. Okay, we're going to continue another point. This is about the okay. So from this example, yes, from the example, we are going to test. You're going to find the both the hypothesis test. You're going to find the interval. Going to check the test whether it rejects H0 or sub H1. Okay. Okay. So the same thing. The inference mean of the normal population, the variance unknown. This is the variance unknown. First one, you know variance. You use the normal graph. This one you don't know variance. Mean this point you have to use t distribution. T distribution. Okay. So normally t distribution is also almost the same normal distribution. It's almost the same normal distribution. We call t distribution. The same estimation formula of the interval x1 minus t alpha over 2, okay, s over n, small and bigger than v, yes, x1 t alpha over 2, s over n plus, okay. This is the t distribution. The same formula for hypothesis test. We have both sides. Hypothesis test H0, H1, H0, H1. We have upper side, lower side, lower side, lower side, the same normal distribution. So it's almost same, but only you use the different distribution. So this is some example to check. This is we are testing the both side. We're testing the both side, whether it is a distribution or not. Okay. So follow this. We have a here. You have to see. They want to check H0 is muy equal 3200 and H1 muy different from 3200. So first one we are calculate X bar and then variance. After we compute T and then compare to reject region after T alpha over 2. Okay, T alpha over 2. So okay, so this is another example for you. Okay, and also this is another example for you to check. So this example is one to test you at the alpha equal 0.1. Sorry, 0.1. That means the battery lifetime is 26.5 hours. This another one test the p-value. The statistic. I mean observing test the statistic or extreme value H0 is true. Yes, this is we have two things for this one. Use the p-value in hypothesis testing. The traditional hypothesis testing given alpha and the p-value approach. P-value approach means p-value is the smallest level of the significance that would lead to reject the null hypothesis test. Okay, this one have p-value. Underline the ideas. If h0 is really true, and is it possible to test the statistic to be such a big or small? This is the ideas. So let's check for this one. This is x1, x2, 3, 4, 5, 6, 7. This is h0, and this is z from the normalization. This is the two sides. This is alpha significant from lower side and upper sides. Okay. Okay. This is a p. Talking about the same about the p value. This is p value is small. It is less likely that the test statistic is small, and x0 is not true. Okay. So regarding to the formula, analytic formulas for both sides. Z0 equal n01. Okay. N0. P for both sides, this is a p value, is equal 1 minus phi nay both sides. P equal 1 minus phi z0 from one side, and p equal z0. Okay, this is from one side. Then h1 must be smaller than 0. H1 must be moist. Bigger than mu0. Okay. This is a p value that's going to be damaged. Okay, from the z value. If from z value, this is a probability 1 minus. So it is two sides. Is it one side? Upper side, lower side. Okay. So they assume that your population and norms. Okay, this is the way you have to calculate. There's some example the same. You have to find out the p value from the example, the same what we are talking earlier. This chapter, you have to find the p value. What is the p value going to be from the example? The same response time of the